Hello everyone, my name is Sasha, and today I want to give you guys a little bit of an introduction about curve sketching. Curve sketching is basically when you try to draw a function given just knowing the equation of the function. And so in these series of videos, which I decided to split up because I thought it would be too overwhelming to do it all in one video, the first video I'm going to demonstrate the basic idea of curve sketching and talk about sign diagrams as well. And in the second video, we're going to walk through a more complicated example of curve sketching using the curve sketching list. And then in the last video, we're going to finish up working on that example, check it in Desmos, and I'm going to introduce a couple tips and tricks for dealing with some more complicated problems. So first, to introduce the idea of curve sketching, I want to take a look at this linear function, which is f of x equals 2x plus 4. And we can draw this function pretty easily. We know the slope and we know the y-intercept, and that's really all the information that we need in order to be able to graph this function. So we know that the y-intercept is 0, 4 because of the b value, and we know that the slope is 2, so we can draw a couple of points that correspond to that slope and go ahead and draw the connecting line. So that was pretty simple. We were able to draw what the graph 2x plus 4 would look like, and curve sketching with more complicated functions is basically the exact same idea. However, it gets a little bit more complicated when you get to things with x's to higher powers, or rational functions, or even using exponents like e to the x power and things like that. Things can get a little bit more confusing. However, there are some really helpful steps that you can use in order to be able to solve and figure out how to sketch the function. So the first thing that we'd be doing is very simple, similar to what we were doing with the linear function, which was looking at the x-intercept, or the y-intercept, sorry. Then we would take a look at the x-intercept if possible. Sometimes it's a little bit too complicated to find the x-intercept straight off the bat, especially if there are third-degree functions or anything higher than that involved. Then we want to look at the asymptotes in the graph and any things revolving around how the graph is behaving in the infinities when x is approaching negative infinity and positive infinity. Then we want to take a look at the first and second derivative, and this is very important. The first derivative obviously shows us the slope at different points along the graph. And we can basically use this to determine if the graph is increasing, going up, or if it's decreasing, meaning the slope is going down. Additionally, at the point where the slope switches from going up to down or down to up, the slope will be exactly 0. And what this means is that the slope is going to be at a maximum or a minimum. And this can tell us where the maxes and mins are in the graph and give us a sense of how the graph is changing at different points. And then the second derivative shows concavity, which basically shows when the graph is bowl-shaped up or bowl-shaped down. And the zeros in the second derivative also can tell us something about the graph. It tells us where there's a switch between bowl-shaped up to bowl-shaped down, or when there is an inflection point. And an important thing to note, or an important piece of notation that I will be using in this video is the idea of sign diagrams. And these are kind of a way for us to express where the graph is positive or negative at different points. So right here, along the top we have the x-axis, and then on the bottom we have the y values corresponding to the x-axis. So we have it ranging from the domain of negative infinity to positive infinity, and this point right here will mark any important point on the graph. Right here, we'll use this function as an example, and this function is 2x plus 4. So an important point to note is when the y value ends up being 0, because then that will shift from the y values being positive to the y values being negative, or vice versa. And in this particular graph, that point of concern is when x is negative 2. So we can go ahead and notate that on our graph. And to the left, or to the negative side of negative 2, we can see that y will transcend into being negative coordinates. So we can go ahead and mark that on our graph, or on our sign diagram. And to the right of negative 2, we note that all x values that are more than negative 2 correspond to a positive y value. So we can go ahead and mark that here. That's pretty simple, but it can get a little bit more complicated when there's a couple more x-intercepts. This basically tells us where the x-intercepts are on a graph. Okay, so that's all I'm going to cover in this video. I hope that you are enjoying this and finding this helpful, and in the next video we will be covering the first 4 steps of the curve sketching process. Bye!